So I'm sure by now we've all seen the amazing images coming from the James Webb telescope. I want to look at one today, and it's of a region within the Great Nebula in Carina, specifically around NGC 3324, the Gabriella Mistral Nebula. It's looking at a star-forming region, and you can see these big, dense hydrogen clouds, which basically look like giant mountains, sitting below this cavernous, almost empty-looking space. That's a bubble, essentially, in the gas, formed by the intense ultraviolet radiation and stellar winds from these young stars. So I'm Paul from Polyman Astro, and today I want to look at this cosmic cliffs image, give you some sort of context for where it is in space, in the southern hemisphere here. We'll start wide and then I'll show you closer and closer views. And along the way, you'll get to see an amateur image, mine, versus the James Webb image, and see that my image is far superior. Just kidding. It'll really show you why they spend the money they do on these space telescopes, because they just blow any amateur equipment out of the water. So anyway, let's dive in. Now, in the southern hemisphere, the stars appear to rotate around the south celestial pole. So as the sun sets and the moon rises here, you'll see the two pointer stars, Rigel, Centaurus and Hadar, as well as the Southern Cross. And you can see that they're rotating around the south celestial pole. Now, NGC 3324 is in the Carina constellation, as you can see here. And as we zoom in, you'll see the Eta Carina Nebula, and then the small round nebula, which is the Gabriella Mistral Nebula. So let's continue our zoom towards the cosmic cliffs. Here is a wider field view of the Eta Carina complex, and you can see Eta Carina here. You can see the Statue of Liberty, and you can see the southern tadpoles. This is an image I took with Telescope, and just here you can see the Gabriella Mistral NGC 3324 region. Zooming in even closer, this is one of my images, and you can see it kind of forms this little rectangle in here on the wider field image. And again, here is Gabriella Mistral. If I zoom in on my image, a little bit more, then you'll see that there's this kind of region here of, it looks like a wall of gas. Very much looks like some mountains, almost a volcano here with this bright white star and this less dense oxygen in the center here. This is the bubble, and this is that dense hydrogen gas cliff face. Here is the James Webb image of the cosmic cliffs, and you can see this little jet here shows up in my image. This little cliff here, this little mountain here, again, little volcano with that bright star there, matches up with this region here. So as you can see, my amateur image just blows the James Webb image off the face of the earth. Just kidding. It's a really great demonstration of why we spend the money we do on these kind of telescopes. That James Webb image is absolutely amazing. The detail in it is absolutely amazing, but also it shows that amateur equipment can do some amazing things too. You can see that little jet of gas that's in the James Webb image. You can see that there is some density differences. The amount of light that's being blocked to my telescope here corresponds with the darker regions, the more dense regions in the James Webb image. Sure, I'm not going to win any awards with my image, but it's amazing what modern amateur equipment can do. So hopefully in the coming months, James Webb will continue to amaze us with images, but I thought it was interesting to give you a context of where that image was in space and compare the James Webb telescope to amateur equipment, just so you can see why it is they spend the money they do. Because the images are just night and day. They're absolutely amazing. Thanks for watching.